And welcome everybody to the Daily Space Weather. Smasho here, coming at you from the Smash News Network, the busted name of news, as we bring you the most comprehensive space weather and detailed imagery of the sun you'll find anywhere in the known universe. We're looking at two wavelengths here as we see some dipping of solar activity here, despite a huge peak in solar cycle 25. This is ionized iron in two different wavelengths of ultraviolet light. That's 131 plus 171 angstroms. We've seen a reduction in the X-ray flux, a reduction in the radio flux. Sunspots have been mostly stable, and no new regions have risen or formed in the past 24 hours. We do have a filament fest continuing, so let's take a look at that. Here's our filament fest wavelengths. That's 193 plus 304 angstroms. And let's go around the horn here to take a look at our named filaments. We've been naming them after living people. So this is the Liver King filament, this one up here. And this one down here is the Zach Toven as it's setting out of sight. And join us on Twitter if you want to name filaments after living people. We've got the Bill Nye filament down here hanging out around the South Solar Polar region. This is the Dan Nigro filament, and thanks, Zach, for naming it that. No, I didn't name the filament after myself. And it looks like we've got some more to name here later in the video. We'll talk about that later. Up here in the northeast, we've got the Dick Van Dyke filament. That's this dark region right here. And the most interesting filament at the moment, because it is in the process of exiting the solar corona, is the Ye filament right here, named for the artist formerly known as Kanye West. The Renee Gable filament has just recently set up here, and once again the Ye filament has become unstable, perhaps fittingly, as it sets around the western limb. Maybe it needed a little more attention. It didn't make any statements about Nazis being good. Continuing on, here is our sunspot view from SDO Intensitygram. And we've got lots of sunspots. Some of them are quite huge. They've been mostly stable over the past 24 hours. We will have one new named group today if it hasn't been named since yesterday. Here's our colorized magnetogram. And these active regions up here appear to be plages so far, not actual sunspots. We don't see any umbrae, despite those areas of high degree of magnetic field organization. So mostly stable here over the past 24. Let's see what's going on in terms of earthquakes before we get back to space. Also volcanoes. So Stromboli continues to erupt. There is a lava flow on thermal camera on the Stromboli volcano slopes. Suwanosejima producing a 5,000-foot ash plume. Semeru producing a 14,000-foot ash plume on East Java. Popocatépetl exploding, flight level 210. It's a 21,000-foot ash plume. Not sure if Fuego is erupting. Don't pole vault the caldera to find out. Sangay in Ecuador is exploding, flight level 200. And we've got, by the way, Sangay is exploding. It's a 20,000-foot ash plume. 24,000-foot ash plume over Peru from Sabancaya as it explodes. Looking at earthquakes, we did have one earthquake quite close to the North Pole. We'll get to it. There is the 90-day bar graph conveniently provided by volcanodiscovery.com. And we've actually shifted the map kind of far south here because we want you to be able to see this quake up here, which we will get to. So scrolling up the list here, we've got pretty quiet here over the past 24 hours, really. There was a 5.0 near the Chile-Argentina border region. So quite a low number of quakes and quite low magnitudes of those quakes. The 5.2 at the Philippines. Was that the largest? I think that might have been the largest quake of the past 24, only a 5.2. And we should note this 4.9 north of Svalbard, very far north there. You can see it way up here. Again, we shifted the map just so that would appear on the list, because this list, if you shift the earthquake you're looking at off the map, it will disappear from the list, which caused a little confusion for me earlier during show prep. So here is the ionized helium all by itself view. You can see this instability happening over here, associated with the ejection of the Yay filament. Yes, the Yay filament. Don't worry, we've got more spectacular imagery for you. How about if we add 131 angstroms? Flaring has been dropping off in the past week as well. So we did see some X-class flares happen in this recent uptick in solar activity. Now things have been chilling a little bit. So the radio flux now down to 228 solar flux units, down 6 points from yesterday. A little reduction in the radio flux there as some sunspots have set on the southwestern limb. There is your 1-year graph to put it in context. And that imagery was good enough to make it onto our thumbnail yesterday. Again, radio flux now 228 solar flux units, as we've seen a new huge high for solar cycle 25. Next, looking at the Space Weather Enthusiast dashboard, and let me just scroll down here for a minute to show you the implications of that high of a radio flux. So, as you can see here, as far as smooth monthly averages go, the 10.7 centimeter radio flux never made it to 175 in solar cycle 24. So, if you're planning on a solar cycle that's weaker than solar cycle 24, keep on dreaming. It's just not happening. We've also seen the sunspot number rise above 200, which was, as far as smoothed monthly averages go, the highest solar cycle 24 ever reached was 128 sunspots. So, them is some facts. Them be some facts there now, y'all, about solar cycles. And NOAA isn't forecasting any sort of geomagnetic unrest or geomagnetic storm conditions. We are expecting a coronal mass ejection impact on the 18th. So tomorrow by midday, we're expecting to see some CME activity striking Earth. I would expect to see a KP4 or KP5 for a brief period of time, not an extended geomagnetic storm condition, but we can expect to see a quality signal there on the solar wind data from that coronal mass ejection that is likely headed our way. Next, KP index is only at 1.67. Geomagnetic calm conditions here as a coronal hole high-speed stream subsides. Let's take a look at what's going on around Earth's magnetic moment from space. That's our Geospace Magnetosphere movie. We show 4 hours of that daily on the channel. Again, geomagnetically calm conditions there. Here's Earth's magnetic moment from the ground. We are seeing a normalization of certain factors here that we will cover in the bonus feature segment of the video, like the total electron content. It's looking a little more normal here. And let's take a look at the real-time solar wind next. So here's our real-time solar wind. It's recently dropped down to about 427 kilometers per second. Solar wind density about 8 protons per cubic centimeter. Nothing to write home about there. Pretty uneventful over the past 24. There are your GOES magnetometers here, looking a little bit more smoothly. Another indication that the coronal hole high-speed stream is subsiding. There is another one on the way. We'll talk about that here in a little bit. First, our top view ecliptic plane field plot. And you can see most of the North Pole current sheet is moving into the earthly directed zone here. So there's our North Pole current sheet. Over on the opposite side, we've got our South Pole current sheet shown in red. And let's take a look at the line of sight field plot. So there's our line of sight field plot. Solar B field depicted in blue, north solar polar field in green, south solar polar field in red. And let's go back 11 years. I just want to take a look at this. I didn't set it up during show prep. I wanted you to see me do it. So there is the current data. All right, let's go back 11 years to the day to 2012. because that's approximately one solar cycle ago. And let's just see how the fields looked back then. So keep in mind that is a different number of frames, so if it looks totally bizarre to you, it's only brought up 15 images there. So if we slow this down a little bit. So that's what the line of sight field plot looked like back then. And here's what it looks like for the past few days, which moves us to coronal holes. So there's our line of sight coronal hole field plot. We've got North Pole oriented coronal holes, obviously. And let's take a look at those via SDO. So these are North Pole, these are North Pole. We've got more North Pole magnetism headed in. If you're wondering about this coronal hole down at the South Solar Polar region, so am I. That is South Pole oriented. So again, there's a long way to go to solar maximum, folks. And don't expect the recent peak to be the high of this solar cycle. You can expect it to go even higher than that because, once again, I've been saying it for a solid year now. We are nowhere near solar maximum, and every YouTube channel that's telling you that is now going to attempt to gaslight you and fill your heads with nonsense to try to make themselves sound right, because they would rather be right than advance the science. Moving to sunspots, and there is what's going on. The likelihood of major solar flares is quite high. I mean, I would say especially from these two, this group up here, 3192 is a massive series of umbrae, and also 3190 is a massive umbra. And there is a bit of a plasma exchange going on between those two groups across the solar equator, and that could be associated with some massive flaring. So let's take a look at sunspots next before we talk about flares. Here's a sunspot scenario. Once again, these groups up here are not sunspots, at least not when we did show prep. They're just plages. And let's subtract the 171 angstroms there to show stable sunspots. So we'll zoom in a little bit, but there's not going to be a lot to see there. Not a lot of evolution, sudden growth, or major reductions in sunspots. They've been stable for the past 24 hours. So next, we'll move to energetic particles, of which we ain't got none. No spikes there in the proton flux. And we brought up the 7-day X-ray graph here, and we normally show the 3-day. There's a 7-day graph, and you can see this general reduction of the solar X-ray output. Here's a little more detail on the 3-day that we normally show. We did have one nearly M-class intensification there just after midnight. Around 0 dark 20, it was at least a C7, C9.42, so very close to an M-class flare there. And let's take a look at where that came from. I think it was this group here. Pretty sure that was this flare. But in any case, once again, I would say the most likely place to see major flares would be somewhere in this area. Because there's a plasma exchange going on in between these sunspot groups across the equator. And there is a lot of chaotic stuff happening in the corona as a result of that. You know, if these sunspots were by themselves, their magnetic loops might look like this. But because they are so close to each other, they've probably got a combined magnetic loop that looks like this instead. And of course, the SDO imagery probably does not show the full extent of the coronal looping associated with those two interactive groups that are interacting across the solar equator. And we've already seen them produce some significant flaring. And let's continue on to a star chart. So if you're up before dawn, you may see Mars high in the sky. It's right near the apex of its path across the ecliptic here over at Lehigh Valley, Pennsylvania. Also, you may find Jupiter up there if you're up in the early morning hours. You can also get a great view of the extremely obvious Orion. And of course, fun fact about the Orion constellation is that if you draw a straight line from the belt stars and then the one star perpendicular, a perpendicular line to the belt points directly to Betelgeuse, the largest single object visible to the naked eye, the red supergiant star. And this new star chart we're using here is Sky and Telescope's star chart, skyandtelescope.org. Let's do a solar system forecast. Next, we've got a crescent waning moon as we approach new moon. Let's advance this 1 week. There's where things will be in 1 week. We'll have a crescent waxing moon by then. Next, we'll look at coronagraphs. So here are some coronagraphs from yesterday. Those are not Earth-directed CMEs. We don't have any from today from GMU, I don't think. Nope, no coronagraph for today yet. And only 23 frames from yesterday. Let's take a look at some more data from Stereo A and Soho Lasco C3 at Lagrange 1. And things are clear here in terms of additional CMEs. Again, we are expecting one to arrive. It'll be a minor glancing blow type impact, producing maybe up to a KP5 minor G1 geomagnetic storm event. Not to last real long, less than 6 hours, I would say. Probably more like 4 hours. Expect to see that arrive tomorrow, Wednesday, January 18th, around noontime, Universal Time. And here are our coronagraphs from the last 24 hours, plus the SDO 304 angstroms. And you may see the Yay filament there becoming unstable toward the end. It is in the process of ejecting, and we will show you it here in just a moment. Let's zoom all the way out. Those minor coronal mass ejections are not earthly directed, which brings us to filaments. So once again, the filament fest continues here. We've got lots of massive filaments. Join us on Twitter if you'd like to name some filaments. Let's see, we've still got the Liver King is, I think, this one here. One of these two is a Dick Van Dyke. Let us know in the comments which one is which, or correct us on Twitter. Perhaps let's bring up the latest image here and offer you the opportunity to name that filament. The likelihood of coronal mass ejections remains at nearly 100%. Don't be surprised to see additional ones directed toward Earth. Remember, folks, we don't need to see sunspots or solar flares to see coronal mass ejections. These are separate phenomena. And there's the Yay West, the Yay filament. Looks like a lot of that is collapsing back toward the chromosphere there. I suspect some will probably also eject. That looks a little bit unsustainable. Great imagery there from the NASA GOES 16 SUVI. And that brings us to our bonus features segment. So here is our satellite charging hazard scenario. We ain't got no charging hazards. It's clear sailing for satellites here at the moment. Again, we are seeing a normalization of the electron flux also here, coming off the floor a bit more in a nominal range here, a normal operating range for the electron flux as it had been cratered for an extended period of time. At quite low levels here, now finally rising back up off the floor, and we're seeing a little bit more organization in the total electron contents. There is the little rise in the electron flux. I think I may have forecasted that yesterday. The NOAA forecast is the green box. The yellow diamond is the observation. There's the one-year chart to put it in context there, again coming off the floor for the electron flux, which is measured at the F layer of the ionosphere by the GOES 16 and GOES 18. That's the bridge between Earth and space, and here's the vibrational frequency, which is continuing to exhibit massive anomalies, global scale massive anomalies in the ionosphere. They may not be evident from this imagery if you're not used to looking at it. I don't blame you. That is megahertz, millions of vibrations per second. There's a lot of stuff shaking at about 300 kilometers of altitude. And here's the anomalygram. This is anomaly in megahertz from a 30-day median, and you'll see huge areas of red and huge areas of blue, high and low frequency anomalies. And if you're new to the channel, you may not realize that the South Atlantic anomaly is now in the South Pacific, somewhere in front of my pointer there, instead of way up here in the South American continent, where it used to be. It is now down in the South Pacific. Also, the South African anomaly has shifted to the north. So that's interesting, I would say. And of course, this calls into question how Earth's magnetic field is formed and all sorts of things like this. Certain aspects of cosmology and indeed geology perhaps are in need of a rewrite. But in any case, that's the data of what's going on in the ionosphere, and it is quite anomalous indeed. Anyway, there's the latest image, 11:45 Universal Time ionogram and 11:45 Universal Time anomalygram. And let's take a look at the electron content. Yes, the total electron content. It's the free electrons going all the way up to the inner portion of the outer Van Allen belt. That's about 12,500 miles of altitude. And free electrons in between can refract that signal, causing GPS errors of thousands of miles. And there have been lots of them in the past week or so. I'll say week to 2 weeks, as we've got these huge blobs of electrons out of place. Now, they are getting a little bit more organized than they've been, but you are still seeing some real serious oddities here. You can see these bands of low electron content mixed in. Also, you see a band of low electron content, a little dot of low electron content over the Caribbean. Also one over the Central Atlantic, one over southern South America. So some oddities happening there in the total electron content. Again, that's the free electrons between your GPS satellite and your handset. The coupled thermosphere, ionosphere, plasmasphere electrodynamics model will show you the most likely places on the planet for GPS errors. And the past week to 10 days have been the most anomalous total electron contents that we've ever covered on the channel in pushing 6 years. We'll be at about 6 years of daily space weather videos come May or June, something like that. We've only missed about 5 days throughout all that time. And let's take a look at the latest intensitygram and latest magnetogram. So these areas here, not sunspots. You can see no umbre there because those are plages. However, these areas up here are certainly sunspots, and they are beta, gamma, delta class. So they'll continue to have a high likelihood of producing solar flares in the coming days. This sunspot down here in the southern hemisphere, parallel with that sunspot group. That sunspot is just gigantic. There's a close-up of that. And the fields, that is beta, gamma, delta class. And once again, there has been some plasma interaction going on between these sunspot groups across the solar equator. So there are, I suspect, huge magnetic loops associated with those groups. Loops from those groups. Besides that, things have been mostly stable here for the past 24 hours. And that brings us to our station identification. Folks, don't be frightened of the galaxy. The galaxy is not scary. Here at the Smash News Network, least busted name in news, we like facts. We like facts. That's probably why we only have 2.67 thousand subs on YouTube, because facts are very controversial, folks. So beware. Beware of the scary, spooky facts that we may cover on the channel. It's very dangerous to cite facts. I know. I'm terribly sorry that it's so dangerous citing all of these facts. Dangerous ideas and thoughts, and I think you're still able to think things. I'm not exactly sure. Anyway, help out the channel by clicking links. So first of all, smashomash.com is our homepage, and welcome to the Neo-Renaissance. Congratulations on realizing the channel exists. If you want to help us out one way, click our links. You can find links to the homepage below the video, and then you'll find us all over the internet, smashomash.com. And of course, we do have a Discord server as well. You'll find a permanent invite link right there on the homepage. You can also find us on Patreon if you want to support us that way. If it's too inconvenient for you to use our own site because you've already got various accounts that you follow on Patreon, support the channel that way. We've got 3 membership levels over there. Look for exclusive content coming from Smash staff soon. We are also on our own subscription services site. So we created our own, which we launched in October of 2021. Smashomash.com/SmashTeam. The best value is the gold annual paid-up subscription. You can find our links on that page as well. Smashomash.com/SmashTeam. And the reason the gold annual paid-up subscription is the best value is because it includes complimentary merch. It's equivalent to getting like 4 months of gold Smash Team level additional content at no additional charge. So thanks to everybody who has supported the channel. There's also a bronze membership level, and we also send out email alerts because of the inability of certain organizations to have software that functions. Today's featured product is the excuse me, the American Democide Survivor. And of course, this design was specifically requested by one of our viewers. So that's how it got so high up on the list, because that viewer specifically asked for a design like this. So congratulations on surviving global democide so far. If you don't know what it is, it's not necessarily malice. It could just be ignorance. Because remember, folks, you never want to blame a conspiracy on that which is more easily attributed and more likely attributed to ignorance and stupidity. But congratulations on surviving global democide so far. And congratulations on surviving a global scamdemic. You can find the links to the Redbubble shop below the video. You'll find the products in order of best selling if you click the link. Thanks to everybody who's picked up merch. Give Smash staff a raise. She needs one. And at the very least, press like, subscribe, and share if you enjoy the content. Tell your friends and foes about the videos. Press the share button. And if you're an influencer, drop us a line. We'd be more than happy to appear on your channel, and vice versa. Thanks to our YouTube subscribers for tolerating the pathetic and putrid censorship on the platform, lo the past 5+ years. So here we are in our meteorology segment. We are looking at sea surface temperature and ocean currents. Now, many of you may already know that this feature right here, you see all that warm water making it all the way to Ireland and Iceland and indeed Norway? That's the Gulf Stream. It's responsible for keeping the entire northern hemisphere warm. Because what happens is if the Gulf Stream is cut off because of too much fresh water being injected from Greenland melting, what happens is you get a frozen Great Britain, frozen Scandinavia, frozen Europe, frozen Asia. The albedo effect takes over, and you get a snowball Earth scenario. That's what the geologic record tells us about the Gulf Stream shutting down. Now, I would ask you, the viewer who's looking at this imagery, is the Gulf Stream shutting down? I mean, I can see currents making it all the way to Norway, and warm water all the way up into the Arctic Circle up here. So, and we didn't have a year without a summer, by the way. And yes, the albedo effect, which is light reflecting back into space, is a positive feedback mechanism for global cooling. Of course, we have negative feedback mechanisms for other types of climate change. I'll just leave that up to you. You can take that as you will. And, Greta Thunberg's knocking at the door, folks. I don't think she's set an appointment. Anyway, here are the surface winds of the eastern world. Powerful low there in the northern Pacific. Here are the jet streams of the east. And we've got a powerful anticyclone here over the west Pacific. That's an upper level high. You can see the clockwise rotation. Here are the jet streams over the Americas. And surface winds over the western world are looking like so. Surface winds of the central world, depicted here. It's a windy day on the Mediterranean, especially the western Mediterranean, and these are the jet streams. And let's blast through the rest of our meteorology. We don't want the video to be too long. And if you're wondering what the state of snow is, well, snow extent is actually kind of on the low side. It's around 1 standard deviation below normal at the moment. So there you go. It crossed below the -1 standard deviation there. And now it's just barely within the plus or minus 1 standard deviation line for the past 1998 through 2011 time frame. Snow water equivalent remains quite high here, well over 1 standard deviation above normal. An indication that there is a lot of snow piled up, so there's very deep snow in some locations, but not a lot of snow extent. So keep in mind, snow extent is a two-dimensional measurement. It does not include snow depth or mass balance, and then the snow mass balance is very close to being outside of 1 standard deviation above normal there, very close to the over 1 standard deviation above normal line based on the 1982 to 2012 average. And by the way, they should be showing the 1982 to 2021 average or something like that by now, because this whole thing is probably shifted farther upward based on the last 6 years of very, very high snow mass balances. Continuing on, here is what's going on over the Americas in terms of clouds and fog. It's our 3.9 nanometer radiation satellite, showing Croissant Earth projected onto NASA's fake spherical Adobe Photoshop image. Of course, everybody that views our channel is well aware that the planet is croissant-shaped, not shaped like an oblate spheroid. Why do you keep believing lies by people like NASA and Neil deGrasse Tyson? Can't believe you think the Earth is spherically shaped and not shaped like a croissant, the French pastry. Here's our weather.gov map, and we've got lots of winter weather advisories there over the U.S. We'll show you some forecasts here. First, we'll scroll down to show you the key. If your location is lit, click your location. We can't go over that. We only show so much information. It looks like some high surf there in Hawaii. Drop us a line if you've got some imagery of that. Here's your forecast for temperature anomaly for the lower 48. You're going to have some anomalously hot days in the Great Salt Lake, surrounded by cold air. An interesting place indeed. And most of the eastern portion of the country are going to see some extremely warm temperatures here, as far as 20 degrees Celsius above normal there. That's a 72-hour GFS temperature anomaly forecast for surface temperature in degrees Celsius. Let's take a look at the pressure and precipitation forecast based on the same GFS 72-hour model. There's what's expected to play out in terms of pressure and precipitation. And since a lot of that precipitation will be falling in the form of snow, let's do a positive snow depth change forecast as well. There's the positive snow depth change forecast in inches based on the same GFS model. Nebraska can expect some significant snowfall, around a foot in the western portion of the state. So lots of snow coming here in the next 3 days to large portions of the U.S. That's a 72-hour GFS positive snow depth change forecast in inches. And And let's move on here. We don't want the video to be too long. Let's show the Euro forecast. There is the next 12 hours of expected new snow based on the European model. There is the next 24 hours. And there is the next 3 days. Again, that forecast shifting the heaviest snow in Nebraska a little bit to the east. However, still expecting quite a bit of snow there. So expecting more snow in the central part of the state there on the European model. That's the European model versus the GFS model. And let's move on to our lightning mapper. We did have some minor thunderstorm activity in the U.S., mainly around the Mississippi Valley and the southwestern portion of the country. Let's see if we have any terrestrial strikes at the moment. We did see some while we did show prep near Phoenix. But at the moment, things have calmed down. Anyway, that's our real-time lightning map, courtesy of lightningmaps.org. Looks like there's a little bit of thunderstorm activity there in northern Spain. And on the banks of the Mediterranean, near Andorra. There's some thunder rolling in there, in some highly unpopulated looking areas there. And let's continue on to our U.S. Doppler radar map. This is where we'll close things out. Some moisture headed into the eastern U.S. here. Let me press refresh on that, as it's not animated for whatever, because reasons. So precipitation is headed our way here in Lehigh Valley, Pennsylvania, which is located right about here, by the way, about 50 miles north of Philadelphia. Here is clouds and fog as that system makes its way to the northeast. And there's the water vapor map. Here's your recap to close things out. U.S. Doppler radar map. Doppler radars are ground-based systems that show vertical motion of water droplets and ice crystals in the air column. This infrared satellite detects infrared radiation at 3.9 nanometers, and that indeed shows clouds and fog when it's too dark to use the visible satellite, which it is over most of the country at the moment. And last but not least, the water vapor map. If your Doppler is not clear, and you understand atmospheric physics, this might clear things up for you. For example, this area right here, this dry air, is going to be, all things considered, more massive than this more moist air. That is a high pressure zone due to the molecular mass of nitrogen versus H2O. Anyway, thanks for tuning into the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-a-Mash, and I am signing off. And may that solar wind be at your back. Facts stated in this video suppressed by big tech for your convenience. Opinions expressed in this video not necessarily the opinions of Smash News Network, least busted name in news.